Good morning, everyone. Today is day 16 of Math 133. We're going to talk about the Chapter 7 review. Uh, that's going to start on page 457 in your course pack. So go get that, page 457 for the Chapter 7 review. Um, I emailed you a key for the final exam, or sorry, the midterm. I did send you the key for the final exam. That would have been that would have been a problem. No, for the midterm, that the test you already took. Um, uh, so take a look at that. If you have any questions on it, let me know. If you're like, well, I put this and the key says this. Did I get that right? Did I get that wrong? Uh, you know, feel free to reach out. Okay. If you took your test at the testing center, um, I have your test. So if you don't remember what answers you put down, message me and I can email you your test from the testing center. Okay. Um, so that way you can compare what you put down versus what's on the key. Okay. Okay. So then uh also I sent a message in Remind, a couple messages about our candy project coming up on Tuesday, not this upcoming Tuesday, not the 17th, Tuesday, March 24th. So a week and a half from now. Um, So, for the Candy Project on the 24th, I'll just pull it up right here. You're going to need to go out and buy some M&Ms and some Skittles, okay? We're going to be collecting data on those, okay? So, for the M&Ms, you can buy whatever you want. You can do plain if you're boring. I, I like the peanut ones or peanut butters. Peanut butter is my favorite. But you can buy they got other ones, right? They got almond and do they still have pretzel? They have a whole bunch of different kinds, right? So anything will work as long as it's just the normal colors, right? If I click on this link, I'll show you what we're gonna be doing. Uh not that one. That's not the link I wanted. Um, okay, while I look for this, here we go. So we're going to be writing down how many of each color are in your bag. Okay. So that's really what we need the M&Ms for. Once we've got that written down, you can eat them. It's not like you're going to be buying them and then wasting them. Okay. Same thing for the Skittles. We're just going to be writing down how many are in your bag. For the Skittles, I do need them to be the normal colors, so those are in the red bag. You can't buy like the wild berry ones or the tropical ones, even though those ones are more delicious. Um, uh, yeah, we just need the normal red bag, the one that has orange, green, yellow, red, and purple. Because for chapter 11, we're going to need to compare both bags, and they need to be the same colors. But again, once you've written them down, you'll be able to eat those on March 24th. Some people have pointed out that there are some online M&M generators, I guess. So if you don't want to purchase any because you're trying to save money or whatever, this one's actually in Desmos, so you can do that. That's fine if you prefer doing that. But you're going to need to buy about 3 ounces. So the normal size bag is 1.6 or 1.5 ounces. Um, and that's not enough. One of the things you're going to hear me say, I'm going to say it a lot this this semester, is a bigger sample size means that you're more accurate. Okay, the larger your sample size, the better. Now, I don't necessarily need you to go buy 3 pounds of M&Ms. I mean, if you do, you're going to be counting for a long time, but you're going to be super accurate. Um, but Anyway, so probably somewhere between 3 ounces and 16 ounces is good. Okay. So I'll probably aim to buy like somewhere between 5 and 9 ounces. So um if you do buy uh one of the if you do buy the 1.5 ounce bag, you'll just have to buy two of them. Okay, that's fine. Um, you need somewhere around like 50 or so M&Ms and 50 or so Skittles. Uh, but I don't expect you to know how many are in a bag, so I'm going to go off of ounces. So somewhere between 3 to 16 ounces. Okay. Uh, anyway, so we don't usually tell people to go out and buy them, at the start of the semester because, they get lost, they get eaten by people, and we don't want, your kids or your spouse to eat your homework, right? So, um, yeah. So, uh, yeah, but with Easter coming up, hopefully there's some kind of good sales for some M&Ms or some Skittles. So, um, okay, so there's that. Um, and I think that's all the announcements. So, we're going to be on page 457 for the uh, Chapter 7 review. Okay. Okay. Um, all right. So, uh, question one, the following graph comes from a random sample of data. Is it reasonable to assume the sample is drawn from a population that's normally distributed? Explain using the graph. So I'm going to go through the worksheet here, just like we go through all of our worksheets. I'll give you some hints, and then we'll go back through and we'll answer all the questions that we skipped over. Okay. So for this one, I think I'm going to skip this one. I think we're going to jump to, um, let's see. So normal curves. Uh, so we have a bunch of different normal curves, and they're all graphed on the same axis here. So which has the largest mean? So the mean is the middle. Okay. So this is my x-axis, right? So uh, larger numbers are to the right, smaller numbers are to the left. So if I draw a line down from the center, that tells me where the middle is. So we're looking for uh, largest mean, so furthest right. Okay, that's what we're looking for here. Now, when you have a normal curve, uh, if they're at the same center, um, then how spread out it is telling you the standard deviation. Okay, right? Standard deviation is one of the ways that we measure how spread out the data is. We had a couple ways to measure spread, right? We talked about uh, the range, we talked about the interquartile range, and we talked about the standard deviation. Okay, so which curve has the largest standard deviation is going to be the most spread out. Okay. Now, when we say most spread out, so the area underneath of each of these curves is always going to be 100%. So in other words, if I was to paint underneath of here or paint underneath of A or paint underneath of C, I would end up using the exact same amount of paint. It's always going to use up 100%. Um, it's just that, uh, the ones that are the most spread out are going to be also be the shortest. Okay. You'll find information about all of this on page 151. Okay. This one you'll find on page 163. Okay. So, okay. Uh, let's move on from there. On the next page, page 458. Uh, find the following for the standard normal curve. For each part, give 4 decimal places. Write P of X notation from StatCrunch. Check the answer. Okay, so um, on page 257, this is our exam notes packet. We have information about the Chapter 7 technology table. Okay. So we're going to be using this all day today. Stat, calculators, normal. Okay. And we're going to be entering in our means, our standard deviations, our z-scores. We're going to be entering in whether we're looking greater than, less than. Okay. So uh, so when you have a normal curve, okay, so the x-axis is actually the z-axis, okay. When you have z-scores that fall somewhere on this uh, z-axis here, you can measure how much area is in between that range. So like if I wanted to say how much of the data is in between -1 and +1 within one standard deviation of the mean is 68%, right? 34% here, 34% here, okay? If I wanted to know uh, how much of the data is less than one standard deviation, I would add up all of these, right? Um, but I don't need to do that. StatCrunch will actually do all of this math for us. So if we were looking at some other crazy z-score, like in this case, z-score of -1.24, that z-score has a corresponding probability that goes with it. And that's what we're going to be doing with page 257, the in StatCrunch stat calculators normal. Okay. All right. So this one is a z-score, find the probability. This one is a probability, find the z-score. Okay. So same idea. Uh, this one is a percentile. When you have a percentile, uh, then we always want to make sure we round down. Okay. Um, and then score is the 85th percentile. Okay. Um, that's fine. Uh, Question number 4, the standard normal curve has areas shaded and labeled. Fill in the 3 missing values. So in this case, we're missing 3 numbers here. So you want to start with the one where you have one of the answers already. So in other words, what I mean is, so these are my x values, or they're actually z values, right? We said this is a z-axis. I'm going to be using z and x interchangeably today. So when I say x-axis, I might mean z-axis, z-axis, might mean x values, okay? Anyway, every z value has a corresponding probability that goes with it. So I can't start with these two because I don't know the z-value and I don't know the probability. I can start here, so I want to do this one first. Now, you probably would have done this one first anyway, but if they had switched this and put the x over here, I would have wanted to start with number 3, okay? Once you've got this answer, though, that's going to tell you this shaded area. This shaded area, I don't know. This white area, they did tell us it's 90%, 0.9101. These 3 A's, A1 plus A2 plus A3, how much should those add up to? They should add up to 1. That's right, Rachel. So because the area underneath of a normal curve is always 1. It's 100%. Okay. So you can use that to find A3. So you'll find that one second. And then once you've got that, you'll find this one third. Okay. On the next page, page 459, question 5 is the same as number 4, where we are missing some a values, we're missing some x values, okay? And so these three a's still add up to 1, they still add up to 100%, okay? These are actual x values, they're not z values now. But in this case, I'm going to need to start with A3 because I have x2, so I can find my A3. I can't start with A1 and x1 because I don't know A1 and I don't know x1. I don't know either of those, okay? So uh, these are also going to be on page 257, okay? Um, these ones I'm going to be using number 3 and 4, okay? So on page 257 in our exam notes packet, there's 4 different things that they list. This is if you have a z-score and you want to find the area, probability, proportion, percentile, rank, those all mean the same thing, okay? Um, so you have your z-score, you want to find your probability, okay? This one, you have your probability, you want to find your z-score. This one, you have x values. So I said I'm going to use z and x a little interchangeably today. They do mean different things. X is when you have numbers that are not, uh, x is when you have the actual data, okay? Remember that we can calculate a z-score. There's a formula for calculating z-score, right? If you want to convert between x and z, you do this, right? You take your x, subtract your mean, divided by standard deviation. We talked about that before to calculate a z-score. So z and x are related, okay? But they're not the same thing. If your mean is at 0, if the middle of your normal curve is at 0, then you have z-scores, okay? That's not what we have for number 5. You can see that the mean right here is not 0. The mean is like 43, okay? Maybe it's this, 43.892. So the mean in this case is not 0, so these are x values. That's why I'm going to be using number 3 and 4. If you have an x value, find your probability. If you have a probability, find your x value, okay? So the only difference between when you have z's and x's is what you put in for the mean and the standard deviation. If you have a mean of 0 and a standard deviation of 1, you have z-scores. If you have a mean of something else or a standard deviation of something that's not 1, you have x values, okay? It's a minor detail. We'll look at it in a second, okay? Anyway, so again, A1 plus A2 plus A3, that equals 100%, okay? And yeah. Part B down here, provide 2 interpretations in the context of the situation. Um, uh, so make sure when you're doing this one, you use a direction word. Okay? What I mean by that is something like more or less or between, okay? So you got to use one of those, okay? Um, Provide an interpretation of x2 using probability. So for this one, for the proportion one, you would say blank percent of all Americans drank, and then you'd fill in the rest, okay? For probability, you would say if we select a random American, the chances or the probability, and then you fill in the rest. Okay. It's the same, it means the same thing. You can write it either way. Um, but we're going to write it both ways in this case. Let's go to page 460. All right. Um, the average daily jail population in the U.S. was normally distributed with a mean of this for each part. Give 4 decimal places, write P of X notation, circle the answer, shade, label the graphs. Okay. Um, so page 257. Interpret the value shown in part A in the context of the situation. This one, you can use probability or proportions. Either one is fine, okay? But remember, you need a direction word. Okay. 30% of the days, there's less than this in the US. It's probably that on a particular day, there's more than, okay. I think I'm gonna skip all that, and we'll go back and we will fill in our answers, okay? All right.